titled Factoring Completely, and we're going to be answering the question, can it be factored further? Okay, so we're going to be completing page 7, but on page 8, we have our math notes, so we're going to read that first. So flip over to page 8 for our math notes. The math notes is titled Factoring Quadratic Expressions. When an expression is written as a product, it is said to be factored. When factored, each of the expressions being multiplied is called a factor. For example, the factored form of x squared minus 15x plus 26 is the binomial x minus 13 times the binomial x minus 2. So x minus 13 and x minus 2 are each factors of the original expression. This example demonstrates a process for factoring 3x squared plus 10x plus 8. First, or number 1, you're going to place the x term and the constant term of the quadratic expression in opposite corners of the area model. So you take this 3x squared and put it in one corner, and you take the 8 and you put it in the opposite corner. Remember, that's one of our diagonals that can multiply. Step number 2, you're going to determine the product of the x term and the constant term. Place this product in the top of the diamond problem. So when you multiply 3x squared times 8, you get 24x squared, and that goes in your diamond problem. Place the x term from the expression in the bottom area, which is the sum of a diamond problem. So this positive 10x goes right here in the bottom of the diamond. Part 4 says to solve the diamond problem by identifying two terms whose product and sum match those in the diamond. So 6x times 4x is 24x squared, and 6x plus 4x is 10x. In this example, the sum is 10x and the product is 24x squared. Solve the diamond problem by determining that 6x plus 4x is 10x and 6x times 4x is 24x squared. Place the solutions from the diamond problem into the two remaining corners of the area model. So this 6x gets moved here, this 4x gets moved here, and then we can factor. This is going to give you the dimensions of the area model, and then write the areas as the product of the dimensions. So along the bottom, we have our 3x plus 4, and along the side, we have our x plus 2. Okay? Flip back over to page 7. And we're going to look at the problem up at the top, numbered 34. Review what you have learned in the previous lessons by factoring the following expression, if possible. All right. So the trinomial they're giving us is 3n squared plus 9n plus 6. There's actually two ways that we can factor this trinomial. We can either factor it to 3n plus 3 and n plus 2, or we can factor it to 3n plus 6 times n plus 1. There are two ways to factor this trinomial. Number 35 says compare your factored expressions for problem 34 with the rest of your class. Is there more than one factored form of the trinomial 3n squared plus 9n plus 6? Why or why not? Why or why not? We are saying yes. There are two arrangements that work. Okay? We get two answers for number 34. Just like you should have yesterday when you looked at problem 26. So down at the bottom of yesterday's lesson, for the trinomial 4x squared minus 10x minus 6, there were 2 possible solutions. How many of you got 2 answers in your group? All right. There were 2 possible arrangements, and the reason has to do with part B. So part B says, why does 3n squared plus 9n plus 6 have more than one factored form, while the other quadratics only have one possible factored form? Look for clues in the original expression and in different factored forms. The reason it has 2 possible solutions is that there's a common factor of 3. 3 is a factor of 3n squared, 3 is a factor of 9n, and 3 is a factor of 6. That's called a common factor. You will also see trinomials that have a factor of 2, or 5, or 4. Sometimes the number can even be larger than 5. Okay? So we're going to look at part C. Part C says, without factoring, predict which quadratic expressions below may have more than one factored form. Be prepared to defend your choice to the rest of the class. So for Roman numeral 1, which is this lowercase I, we have 12t squared minus 10t plus 2. The greatest common factor of all of these is 2, because 2 goes into 12t squared, 2 goes into negative 10t, and 2 goes into 2. A number always goes into itself, right? So next to it, I want you to write the number 2, because that's the greatest common factor. Roman numeral 2 is the trinomial 5p squared minus 23p plus 10. It looks like it's going to have a common factor of 5 because 5 goes into 5p squared and 5 goes into 10, but 5 does not go into negative 23p. It is not a common factor. So we leave that one blank. Roman numeral 3 is the trinomial 10x squared plus 25x minus 15. Hopefully you can count by 5s. 5, 10, 15, 20, 25, 30, 35, and so on. And you can recognize easily that 5 is a factor of 10x squared plus 25x minus 15. If you're not good at your multiples and multiplying and dividing, you definitely want to have your calculator out or your Chromebook with your Desmo Scientific Calculator. All right. Roman numeral 4 got pushed to the next row, so it's down here. This trinomial is 3k squared plus 7k minus 6. You should always at least try the leading coefficient to see if it's a common factor. 3 is a factor of 3k squared, and 3 is a factor of negative 6, but 3 is not a factor of 7k, so we're going to leave that one blank. That means that the 2 with their common factors were Roman numeral 1 and Roman numeral 3. Okay? Any questions on problem 35? Okay. Jumping down to 36. On question 36, it says, in part C of problem 35, you should have noticed that each term in 12t squared minus 10t plus 2 is divisible by 2. That is, each term in the expression has a common factor of 2. Part A, an expression is considered completely factored if none of the factors can be factored further. Often, it is easiest to remove common factors first before factoring with an area model. Rewrite the expression 10x squared plus 25x minus 15 with the common factor factored out. So hopefully you recognize that each of these 3 terms has a common factor of 5. So we're going to pull the 5 out in front, and then inside the parentheses, we're going to write what's left. If we take 10x squared and divide it by 5, we get 2x squared. If we take 25x and divide it by 5, we get 5x. And if we take negative 15 and divide it by 5, we get negative 3. Okay? So this is a lot of multiplying and dividing. Again, if you are a person who struggles with multiplying and dividing, you definitely want to use a calculator. Part B, down at the bottom, says, your result in part A is not completely factored because the trinomial factor can still be written as a product of 2 factors. So we already pulled out the 5. We're left with our 2x squared plus 5x minus 3. So we can take that trinomial and plug it into our area model. So we put our 2x squared in this box, our minus 3 in the adjacent box, and then we determine what 2 terms multiply to get negative 6x squared, but add to get 5x. That would be our plus 6x and our minus x. Then we can completely factor it to 2x minus 1, which was across the top, and our binomial of x plus 3, which is along the side. Okay? For problem 37, you're going to work in your groups of 4 to completely factor each of the following expressions. So when you look at A, you first want to pull out a greatest common factor, something that goes into 5x squared plus 15x minus 20. If you think you know what the greatest common factor is, write it down right now. Then for part B, you have 3x squared minus 6x squared minus 45x. If you think you know what the greatest common factor is for part B, write it down now. Hint for part B is that it has a numeric part and an algebraic part. So if you can recognize the numeric part, great. But there's also an algebraic part that is going to be a factor for part B. Okay, go ahead and pick up your desk and turn it into your group of 4.